All right, let's look at the Lagrange multiplier method. All right, so the problem is this. We want to either maximize or minimize a function of two variables, but there's one more constraint satisfying this constraint here, g of xy equals c. All right, then we want to either find the maximum or minimum. All right. So in order to do that, what we can do is we can solve this following equation, and I'll explain why this is an equation. All right, so we take the gradient of the function you're trying to maximize or minimize, set that equal to some constant lambda. All right, so this guy right here is called the Lagrange multiplier. So this is the Lagrange multiplier. Right, so this is just some constant lambda and times gradient of g. Right, so basically what it's saying is that the gradient of f, which is a vector, is a constant multiple of a gradient of g, which is the constraint equation. Right, so here's an example. Let's say you have a level curve for z equals f of x comma y. So you have z equals f of x comma y, and here's the level curves. So level curves. Right. So it's going to be a hill. So level curve. So this is level 0, level 10, level 20, and level 30. So the hill is again. So this is a hill where this is probably the top of the hill. All right. Let's say the hiker took a certain path, right? So which is in purple. So let's say this curve is the path of the hiker, right? Which corresponds to this constraint. So this is g of x comma y equals some constant, right? All right, then what we want to do is we want to, let's say, find the maximum height the hiker achieved, the maximum altitude that the hiker achieved, right? Then you can see that we can eyeball where that happens, probably right here, right? And right at the level curve for 20. All right, so what is special about that location, right? So here, remember that the gradient of f is perpendicular to the level curve. So we know exactly which way it's pointing. Gradient is actually pointing perpendicular to the level curve. So this is the direction of f, right? And also, if you take the gradient of g, this is basically a level curve because you're setting a function equal to a particular constant. So this is really a level curve for g, right? Then if you take the gradient, of course, it's going to point perpendicular to g, the curve. So it could be, it could be pointing this direction or the same direction as v, but it's making sure that it's perpendicular to the path of the hiker, right? But all we know is the gradient of f is always perpendicular to the gradient of g if it achieves the highest point, right? So that's what this equation is trying to say. So here's a condition: gradient of f, right? So it's perpendicular to the level curve, and also gradient of g, and this is a perpendicular to the path of the hiker. Right? It's a constant multiple, which means that they are parallel, right? Either pointing in the same direction, or I guess it could be completely the opposite. Right? So we know that the gradient of f and gradient of g are parallel when the maximum occurs or minimum occurs. right? So we can use this equation to find the maximum value of a function or minimum value of the function. So let's try to look at this simple example. Let's say we want to find the maximum value of this given function, f of x comma y equals x times y, subject to, right, x plus 3y minus 6 equals 0. All right, so what we can do is we can rewrite this equation a bit. So we want g of x, right? So g of x is going to, g of x comma y, sorry. G of x comma y is going to be, I can probably do x plus 3y as a g of x. And I can just move the negative 6 on the other side, so it's going to be a positive 6, right? All right, let's set up this equation. So let's find, gradient of f. All right, that's easy. Partial with respect to x is y. Partial with respect to y is x. So this is it. All right, so let's find the gradient of g. All right, so this is going to be partial of that is going to be 1. Partial of that with respect to y is 3. And that's that. All right. So we are setting this equal to, so gradient of f is equal to some constant lambda times gradient of g, which gives us two equations, right? So you have, so first component is y has to be equal to lambda times the first component of gradient of g, which is just lambda, right? And the second component y, the second component of gradient of f is x, has to be equal to lambda times 3, so 3 lambda, right? So we can get this equation, and also we know that this has to be satisfied. We know that the constraint is x plus 3y is equal to 6, right? So that's the given constraint. All right, so we know something about the x and the y. We can actually express them in terms of lambda. So what you can do is plug this guy in for y and plug 3 lambda in for x. So what you get is going to be, so this is going to give us, right, x is 3 lambda, and y is lambda, so 3 times lambda, so 3 lambda is equal to 6, which gives us 6 lambda is equal to 6, and then we can just divide through by 6 to find the lambda value to be 1, right? So if lambda value is 1, we know that the x value is 3 lambda, so 3 times 1 is 3, and the y value is lambda, so y value is 1. So the maximum value occurs at x equals 3, y equals 1, which is x is 3 times y is 1, right? 3, right? So this is the 3 is the largest possible value of this function x times y, satisfying this following equation. All right, that's it. I hope that this was clear.